Hi, my name is Amir Durrani. I'm a senior cloud infra architect with AWS Professional Services. Today, I will talk to you and do a demonstration of how to resolve on-prem DNS in hybrid environments. So what does that mean? That means that the customers with hybrid cloud environments want to continue using their on-prem DNS for name resolution requests. These requests are originating from the resources that have been instantiated in their VPCs, virtual private cloud within AWS, and or been migrated from the on-prem data center into their AWS accounts or VPCs. These resources are actually trying to communicate with the resources that are still residing on-prem using the DNS fully qualified domain name. And that is what the outbound resolution is, DNS in hybrid environment, where the request for DNS name resolution originate from the VPCs, resources in the VPCs, and the resources that are being queried reside in on-prem data center. And the DNS infrastructure that is resolving those queries for name resolution also reside in on-prem. And we are forwarding those queries to the on-prem DNS servers using key element services, which is what I will talk about in just a little bit. So what is the use case? The use case is that the customers now can build applications that span large number of VPCs, and they use shared network services like DNS or shared services, Active Directory, DNS within those VPCs, and still be able to maintain control with which accounts they share it with external or internal to the AWS organization. Now, they don't have that operational burden of distributed environment and taking care of and managing multiple environments for the DNS, multiple servers instantiated or appliances installed, virtual appliances. So imagine 100 or even 1,000 of VPCs in an organization, AWS organization for a customer. And they're trying to maintain a hybrid environment for whatever reason, maybe for a couple of years while their applications are getting migrated to AWS, or there are some legacy applications they may not migrate at all, but they are business critical applications. So they may have to maintain hybrid connectivity. Now, they may choose to consolidate some data centers, but still maintain hybrid connectivity. And in that case, they would like to continue to use for some time, long period of time, or maybe permanently, the DNS infrastructure that is, they have invested heavily, for example, Infoblox, for hundreds of thousands of dollars in multiple grids. So there are some certain key elements that I will talk about in this environment, and I will talk about using the slideshow. So one of the key elements for this type of environment and scenario is you have multiple accounts, and it could be in a same region or multi-region accounts. That even makes it a little bit more complicated and challenging. But same technology, same services, same process to use and share across multi-region as well. In this case, this slide shows a sample or example account strategy or structure. Using AWS Control Tower service, this structure can be created and maintained. What we need to focus here is not AWS Control Tower, but what we are focusing here is the infrastructure organization unit and multiple other organization units in production OU. And in infrastructure OU, we have two very important accounts, networking account and shared services account. Depending on how your IT organization internally is set up, or in some IT organizations, networking account, meaning the networking engineering, networking operations team, is responsible for maintaining and managing DNS. In other organizations, a shared services account takes that role. Whatever the case may be, this is where the shared services or network account is where the DNS infrastructure is configured and shared across multiple accounts, maybe prod account, test account, or dev account, and maybe sandbox as well. I'm going to build this completely in a second. Why this slide, right? So the second key element is, of course, a inter-VPC routing scalable structure or infrastructure or architecture. So transit gateway service is the service that provides the inter-VPC routing at a scale. In this case, we're talking about multiple accounts, maybe many regions. And we're going to focus on this shared services account is one of the accounts that the DNS service is being configured, operated, and shared in with other accounts. So a routing architecture needs to exist. And we're not talking about transit gateway here because it could take hours to talk about it. But our focus is the DNS resolution and using the one account to create and the others to share with. I'm going to build this again. So this is a typical name resolution using a public name resolution using the VPC resolver. So in this VPC, there's a default VPC name resolver that gets instantiated whenever you create a VPC. In this case, there's an instance. The instance is trying to reach www.amazon.com. It's a public website. The resolver gets the request. If the resolver has in the cache, meaning that it has resolved it for any other instance in the past and puts in the cache for a certain amount of time, it will send the response back to instance. The instance is now able to use www.amazon.com that resolves to IP address 5432, which is obviously made up. It's not the actual IP address, but for the example. And the instance is happy. In this case, at the bottom, Route 53 is also hosting the internal zone. The second scenario is the instance sends a request for www.amazon.com. Resolver doesn't have it. It sends a recursive lookup to root servers, the public root servers. The public root servers will point it to .com servers. .com servers will finally point it to Amazon.com authoritative servers, and the authoritative servers will respond back with the IP address for Amazon.com, and instance can access. The second scenario, again, go ahead and build it. It's a little different in that the private zone on the right-hand side resides in the data center hosted on these two DNS servers. The instance will send a request for ntc.com. In this case, ntc.com happens to be a private zone. dc1.ntc.com, dc1.ntc.com resides in the data center. Request goes to the resolver, VPC resolver. Resolver now has an option, because it's not a public name to IP resolution, it sends it to the DNS outbound endpoints, which are part of the DNS resolver rules, and the rule has been shared with this VPC through the shared services account. I'll show you in a little bit, and then a demonstration as well. So the resolvers through the endpoints, which are basically elastic network interfaces in each one of the availability zones within VPC. Through that, and direct connect is, of course, it could be VPN between data center and AWS VPC as an interconnect. The request reaches the DNS servers. The DNS servers will resolve the request and send the response back through the endpoints to the resolver, and EC2 instance now can talk to dc1.ntc.com. The last slide basically shows a very important key element and a service, Resource Access Manager. As the name implies, a Resource Access Manager allows you to create resources in one account and share with other accounts and external accounts as well. So shared services account is where in this case, a resolver rule is created and configured and then shared with the production account. Now, the resolution is the same. It just shows that instance is trying to talk to dbtest.company.com. dbtest resides here, IP address 10.0.0.152. These two DNS servers on-prem will resolve for this. The instance sends it to resolver, goes to the endpoints through the direct connect to the DNS and comes back same way. EC2 instance now can talk to using the DNS fully qualified name for the database server can talk to it. Now I am going to get into the demonstration and show how this is configured. So this is my account structure. And I am going, in my case, it could be different again, it could be networking account, but I am going to use the shared services account to create this DNS construct for outbound name resolution. And first thing, I'm going to go to management console, and then from management console, I am going to route 53, where I am going to configure the outbound endpoint and the rules. So I am in shared services account. I am going to, on the left-hand side menu, outbound endpoint. Before I actually create the outbound endpoint, I want to make sure that I am in the right regions. Although the Route 53 service is global, but where you want to create the endpoints are regional constructs. So I'm going to create the outbound endpoint in Oregon or US West 2 region. I'm going to give it a name, NTC out, choose my VPC. Security group, I already have a security group configured, which allows inbound DNS UDP 53. Now I'm going to choose two IP addresses, one within each availability zones for each one of those ENIs that I showed. Just going to quickly, for the reference, these two ENIs or the endpoints that we're creating, right? So I'll choose my subnet in one availability zone, allow it to automatically assign. Optionally, you could specify an IP address. Second availability zone, second subnet, and I would let it choose. And of course, a tag can be assigned optionally. I am going to let it create. It's going to take a couple of minutes. I'm going to pause the video and come back when it's done. Okay, so the endpoints are created. They show operational, two IP addresses. And now I'm going to go ahead and create the rule. So its internet resolver rule exists for the public resolution that I showed in one of my slides. Now I'm going to go ahead and create the rule. I call it OutNTC. Two options. Let the request go to the system or forward. In this case, I'm going to forward the request for anything ntc.com domain and associate my VPC and outbound endpoint that we just created. And now the two IP addresses of the DNS servers that we are going to forward the request to. In my case, these are the two IP addresses. And before I click on submit, I just want to show you guys that this is what I am running in my simulated on-prem environment. Two domain controllers that are running the DNS service as well. So private hosted zone for ntc.com, DC1 and DC2, 10.0.0.10, 10.0.32.10 is what I exactly put in here. So it's clear. Optional tag, of course. Submit. And it is going to take a little bit to associate with the VPC. Here it's creating. So I am going to go ahead and while it's doing this, I am going to log in, actually not log in right now. I am going to go to the resource access manager and do that part where I am going to share this resource with my organization. duplicate this. And in this case, I am going to look for RAM, which is Resource Access Manager, in my shared services account. And from here, I am going to, these have been deleted, so don't exist anymore. So now shared by me on the left-hand side within Resource Access Manager. I'm going to create a resource to share with my organization. Call it NTC out resolution resolve or whatever else, a name that makes sense can be assigned here. Multiple different resources that can be shared using AWS Resource Access Manager. In this case, we'll resolve the rules, and we are sharing our rule that is existed. Optionally, we can do a tag for it. The next screen basically shows the IAM roles that it creates for the service to work. Here we have two options. Allow sharing with external principals. So for example, you want to share it with the accounts that are not part of your AWS organization. Could be partners, vendors, and such. In my case, I'm going to choose sharing with principals in my organization only. That is where the control and security comes in, where you can pick and choose the principals inside and outside the organization. The type of principals are a specific account, an organization, an OU, IAM role, or user, so you can actually be very, very precise and concise in where and how you share your resources. In my case, I'm just going to go ahead and share it with my organization. Add it, select this, go next. And here's the summary page. I am going to go ahead and tell it to create my resource. And it is it's associating with my organization. It's going to take just maybe a few seconds to a minute. And while it's doing that, I am going to now go ahead and log into my product account where I can use this service and construct for name resolution within my VPC. So I am going to go to Resource Access Manager. And I don't know why it shows double, but under my Resource Access Manager on the left-hand side, I am in Oregon region. I am looking at the resources that have been shared with me. And sure enough, my outbound resolver rule shows up here, and I'm going to click into it. That's my resolver rule, and the resolver rule has two IP addresses for forwarding to my DNS. I am going to associate my VPC where I want to resolve the name. It's going to take a couple of minutes. Again, I'm going to pause the video and come back. Okay, so my association is complete with my VPC, and now the moment of truth. I am going to use one of my EC2 instances that are running in this VPC, which is the production VPC, and I am going to resolve to the DC1 and DC2 or ntc.com in general. I already have bind utilities installed on this instance. You may have to install it if it's not there. So first thing, I'm going to make sure that this has the VPC resolver. It's pointing to the VPC resolver. And it does. That's my VPC resolver. So now I'm going to go ahead and look for ntc.com, and sure enough, ntc.com comes back. The query comes back for 32.10 and 0.10, which is these two servers, which are hosting the ntc.com zone. And now if I do a specific query for, let's say, dc1.ntc.com, it resolves to .10. And if you notice that the server, the resolver is the VPC resolver, but it is forwarding those requests through this mechanism that we just created and shared, and the resolution is coming back. I just wanted to kind of re-emphasize that. And if I do for, let's say, DC2, and it resolved to 32.10. So my name resolution is working using the on-prem DNS servers, which are these two servers hosting my private zone. I hope this was helpful, and I appreciate everyone tuning in today, and happy cloud computing from AWS.